All right, my math counts people. Here we go. We've got workout one from the 2026 um, problem set. So the workout problems, they show that there's a calculator up here. So these are the ones where they expect you that you might have to use a calculator to work them out. Now you don't always need a calculator to work these out. In fact, there's several problems in here where I never used a calculator at all. But that option's open. Okay. So this is for the what's it called, the target round. Yeah, these kind of are like target round where they give you two questions at a time and on like 5 minutes to do them or something like that. So that's what these are practicing. So here we go. Like usual, if you haven't already done these problems, after I read the problem, pause, and then you can watch me solve it. Give yourself a chance to work out these, and then there might be a different way that you solved it that I didn't. And you can leave a comment or whatever you want to tell me a different way to do it. Here we go. All right, so a certain brand of almond milk, favorite brand, certain brand, has 30 calories per cup. If there are 8 fluid ounces in a cup, which there are, and the carton holds 100 fluid ounces, how many calories are in a full carton of certain brand almond milk? Okay, so this is a dimensional analysis problem, really, because we're starting off with 30 calories for every 1 cup. And we want to end with total calories. Okay, so I'm going to have to get rid of cups eventually. So it says there's 8 fluid ounces in a cup. So I can convert this by putting 1 cup in the numerator. Oh, CUP. And then 8 fluid ounces in the denominator. Cups cancels. Now I'm in calories per fluid ounce. A carton holds 100 fluid ounces. Okay, so now if I multiply this by 100 fluid ounces, now we notice that the fluid ounces has canceled, and what am I left with? Just calories, right? Because the cups have canceled, the fluid ounces are canceled, and now I'm in calories, which is what I want. I want the total number of calories. So all I have to do is 30 times 100, which is 3,000. 8. So it's 3,000 divided by 8, and I used my calculator earlier. It comes out to 375. Next. Oh, this one. All right, what is the total number of digits? Okay, remember to read, because when I first did this one, I did not read. The total number of digits used when the first 500 positive even integers are written. Okay, so so they want to know how many digits did we use for these 500 numbers. Now they're even. So I know that my lowest number is 2 because it's even. And my biggest number would be 1,000, right? So my biggest number is 1,000, that's 4 digits. There is one 4-digit number. So to write that number, I have to use 1 times 4, 4 digits. All right, so that's at the top. At the low end, single digit, 1-digit numbers. Spell. So for 1-digit numbers, that's 2, 4, 6, and 8. There's 4 of those. There are 4 single-digit numbers. Now, each of those single-digit numbers only uses 1 digit, so I need 4 digits for those 4 numbers. I have now accounted for 5 of the 500 digits that I need to use. All right, so I still need to find out how many digits I'm going to use for all the 2-digit numbers and the 3-digit numbers. All right, so between the 2-digit and 3-digit numbers, I should have 495 numbers. Let's start with the 2-digit numbers. These would be the easiest ones. So I know that the 50th digit is 100, right? Because they're even numbers. So that means 49 of my digits are 1 and 2 digit numbers. Well, I already counted for 4 of them. So that must mean that I have 45 2-digit numbers, because our 50th digit is 100, a 3-digit number. So the 49th digit would be a 2-digit number. So now I've got 49 digits between 1-digit and 2-digit numbers. Since there are 45 2-digit numbers, each of those 45 is going to use 2 digits. So that's 90 digits. All right, so now I have 45, 4, and 1. I've used 50 digits of the 450 digits that I had when I started here. So that must mean, without having to do a ton of calculation, that there are 450 3-digit numbers. So now I know that I've got 450 3-digit numbers. So 450 times 3 is 1350. So that's how many digits I'm going to have to use to write these 450 3-digit numbers. So now I just have to add this up. 4 digits from the singles, 90 digits from the 2-digit numbers, 1,350 from 3, and 4 from the single digit. Comes out to 1,448 digits. So you can see kind of right now, we don't have to use our calculator. The calculator is just kind of a convenience at this point. Some of these problems you kind of have to use calculator, but right now it's just been a convenience. All right, 2 photographs have equal areas of 16 square inches. One is a square measuring 4 by 4. So we've got I'm going to just read the problem, then I'll describe. And the other is a rectangle measuring 2 by 8. Each photograph is surrounded by a wooden frame that's 1 inch wide on all sides. What's the absolute distance between the areas of the 2 frames? All right, so I've got one picture that is a 4 by 4. One picture that is a 2 by 8. Okay, there is a 1 inch frame going around each of these. So if it's 1 inch, that means on the square we have to have 6 inches over here because there's an inch on this side and an inch on this side. And then this is going to be 6 inches because we got 1 inch on this side and 1 inch on this side. And same for the other 2 sides. So the interior area is 16. The exterior angle is 6 times 6, 36. So the entire area is 36. The inside area is 16. That means the frame area, which is what I'm looking for, is the difference between these two. So for the square one, we've got a frame area of 20. Doing the same thing over here, this side would have 4 inches for the frame because we have an inch on either side. This side would have 10 inches. So the interior area of the picture is 16 again, but the exterior angle is 4 times 10, 40. So 40 minus 16 ends up being 24. Brain stopped working for a second there. So what's the absolute difference between 20 and 24? It's 4. There we go. So I found the area of everything and then subtracted the area of the picture, and that gave me the area of the frame. Number 144. A car can travel from Sprintville to Countdown City in 3 hours, traveling at a constant rate. If it travels at another constant rate, that is 10 miles an hour faster on the return trip, it can travel back from Countdown City to Sprintville in 20 fewer minutes. How many miles are between Sprintville and Countdown City? All right, this is a dirt problem. Dirt is distance equals rate times time. So, we're going somewhere, we're coming back. So, I don't know the distance. But what I do know is the distance is the same. So I've got two situations. I'm going there and I'm coming back. In both situations, they have the same distance. I'm going to just call that distance D. All right, when I'm going there, it's going to take 3 hours. That's the time. Traveling at a constant rate. I don't know what the rate is. It's just R, the constant rate. So going there, I'm going to go a certain distance for 3 hours at a constant rate, R. Coming back, it's the same distance. But we're going to be going 10 miles an hour faster. So our rate is the rate that we were going before plus 10 more, R plus 10. And then we're going to go in 20 fewer minutes. Okay, now this rate is in hours. So 20 minutes is a third of an hour. So it's going to take me 2 2/3 of an hour to get back. I'm just going to change this into 8/3 of an hour. So my time is 8/3. Because it's 20 minutes less, 20 minutes is a third of an hour. So if it took me 3 hours to get here, it's 2 2/3 of an hour to get back. It's just going to be easier to leave this as a fraction. All right, so here's what I got. If the distances are the same, the other side of the equation also has to be the same. So now I can write that 3 times R, this part here, is equal to this part here. I'm going to go ahead and distribute this real quick. So R times 8/3 is 8/3 of R. And 10 times 8/3 is 80/3. Personally, I don't like these denominators. Let's just multiply everything by 3 to clear our fractions. It'll make it easier to look at and be much prettier. So multiplying everything by 3, I get 9R equals 8R plus 80. Oh, this is kind of nice. I subtract 8R from both sides, and I get R equals 80. Okay, I now know the rate in mile. Wow, he's going 80 miles an hour? That's not safe. Okay, anyways, we're not going to worry about that. I'm distracted. How many miles are between Sprintville and Countdown City? Okay, so I know the rate now. I'm looking for the distance. Well, let's use this top equation because it's easier. Now I just have to do R is 80, so the distance is 80 times 3. That's 240. Didn't need a calculator. Beautiful. Love the dirt problems. Some of my favorite things to do. All right, 3 distinct prime numbers form an arithmetic sequence, and their sum is 111. What's the least possible value of their product? Okay, so we've got 3 numbers, and these numbers are all prime numbers. Okay, and they're arithmetic. So if they're arithmetic, I'm adding by the same amount. I'll call that the common difference here each time. Okay, so that means this middle number should be 111 divided by 3. It should be the average, right? It should be right in the middle. So 111, definitely 3 goes into it because 1 plus 1 plus 1 is 3. So we end up with 37 as our middle number. Okay, so that's prime. Everything's looking great now. I just have to find out what these other 2 numbers are on this other side. And if you think about it, there's a ton of different numbers that we could use. So what they said is, what is the least possible value of their product? Okay, because there's more than one way to do this. So let's just write down some of the prime numbers. The lowest, and here's another thing that I know. Since these are all prime numbers, one of our prime numbers is positive, 2 is. But if we're adding all three of these together and we're getting an odd number here, and every prime number except for 2 is odd, we can't use 2. Because if I use 2 and an odd number here, odd plus even would be an even number. So I need 3 odd numbers here, so I can't use 2. All right, so the prime numbers other than 2 would be 3, 5, 7, 11, 13, 17, 19, oh man, so 23, 29, 31, 37. That's the one that's in the middle right there. 41, 43. I'm just going to stop right there. All right. The difference between 37, I can't use 41 and 31. The reason why I can't use 41 and 31 is because from 37 to 41, that increases by 4, but going this way, it increases from 31 to here, it increases by 6. So I need to find numbers on either side where we're increasing by the same amount. Okay, now, we want the least possible value of their product. The least possible value means I need some small numbers here. If I use big numbers, that's going to be a big product. So what's the smallest number I could use? The smallest number would be 3. All right, so from 3 to 37, what's that common difference there? It's 34. So since it's arithmetic, we should add 34 over here. Now let's check to see if this number is also prime. 37 plus 34 ends up giving us 71. Ooh, a prime number. Okay. So at this point, I use the smallest number possible because I want the least product. If we can use small numbers, our product will be smaller. So this is the answer for this. These are the 3 numbers. Trust me, I tested out a bunch of other numbers just to see. And this is the smallest one because we want to use the smallest prime number possible, which in this case would have been 3. And now we just have to multiply these 3 numbers because we want the least product. And that comes out to 7,881. Okay, finally, we do need a calculator for this one. Whew. All right, this one's a long video. All right, next one. A number is chosen at random from a set of consecutive integers, 1, 2, 3, up to 25. What's the probability that the number chosen is a divisor of 5 factorial? All right, so 5 factorial is, express your answer as a common fraction. 5 factorial is 5 times 4 times 3 times 2 times 1. So basically, we've got 5 to the first, 3 to the first, and then 4 is 2 times 2. So we have a total of 3 2's. All right, so what is the probability the number chosen is a divisor of 5 factorial? Okay, so let's just go through the numbers 1 through 25. Does 1 go into this number? Yes, of course it does. Does 2 go into this? Yes, because this has 2 to the third. That has 2 2's. Does 3 go in? Yeah, there's a 3 right there. Does 4 go in? Yeah, 2 to the second. We have 2 to the third, so 4 works. Does 5 work? Yes, there's a 5 right there. Does 6 work? Yeah, because I have 3 times 2 right here. So 6 definitely goes in there. Does 7? No, 7 doesn't go in there. Does 8? Yes, 2 to the third is 8. Does 9? No, I only have 1 3. Does 10? Yeah, I have 5 times 2. 10 works. Does 11? No. Does 12? Yes, 3 times 4, because I've got 2 to the third here, so that works. 12 works. 13, no. 14, there's no 7, so that's not going to work. 15, yes, 5 times 3. 16, no. I only have 2 to the third, that's 8. So 16 is not going to work. It's not going to go in there. 17, no. 18, that'd be 9 times 2. I only have 1 3, so that's not going to work. 19, no. 20, yes. 5 times 4, because I have 2 to the third, so the 2 to the second. So that's going to work. So 20 works. 21, no, because I don't have any 7s. 22, I don't have any 11s. 23 is prime. No, that's not going to work. 24, that doesn't work either. 25, no, I only have 1 5. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, I missed one. What was the other one that I missed? 1, 2, 3, 4, 5, 6, 7, doesn't work. 8, 9, 10, 11, 12, 13, 14. Dang it. Where did I miss one? I was talking and I can't think now. 12, 13, 14, 15, 16, no. 17, no. 18, no. 19, no. 20, yes. 21, 22, 23, 24, 24 is 6 times 4. Oh, sorry. 24 works. 3 times 8. It's hard to talk and think at the same time. All right, so 24 works because this is 3 times 8 right there. Wow. All right, so I've got 12 out of a total of 25. It's really hard to talk and do math at the same time. It's harder than it looks. Oh, that's embarrassing. All right, number 47. What is the sum of all possible palindromes less than 2025 that are divisible by 99? This one was ridiculous. Okay, so palindrome, remember, has to be the same backwards and forwards. I just started with 2002. Okay, so that's the biggest palindrome up to 2025. Now, if it's divisible by 99, 99 is 9 times 11. I'm just going to stick with this because at this point, the rule for 9s, to see if 9 goes into a number, I basically need a number that 9 and 11 will go into. There's a rule for 9s. If the digits add up to a multiple of 9, the 9 goes in there. There's a rule for 11s. The rule for 11s is if every other digit, if you add every other digit up and subtract and you get 0 or 11, then 11 goes in there. So we're going to test each of these. 9 does not go into this one. So that's the only 2000 palindrome. So now I'm going to start with 1991. 9 doesn't go into that. That doesn't work. I'm going to try 1881. 9 goes into this. So 9 goes into this because if I add all these up, I get 9 plus 9, 18. 9 goes into 18. So this is a number that's divisible by 9. Now we check to see if 11 works. Here's how you check and see if 11 works. You add every other number. These two numbers make 9. These two numbers make 9. 9 minus 9 is 0. So if you get 0 or 11 when you do that, then 11 has to go into it. So this is one of our palindromes. That one works. Okay, we would start going through it. We're going to see that there's hardly any other numbers that work. 9 doesn't go into that. 1661. 9 doesn't go into that. 1551. 9 doesn't go into that. We would just keep on doing this process forever until we get down to the last one that does work, which is 99. That's our last one that does work. So we would take 1881 plus 99, and that ends up giving us our answer of 1980. So we can just kind of go through systematically 1441, 1331, 1221, 1111. Just keep on going, and you're going to see that when you get down to it, the last one that actually works is 99. There's got to be an easier way to do that one, but that's how I did it. All right, 148. The average height of a professional basketball player is 78 inches, and there are typically 15 players per team. The average height of a professional baseball player is 74 inches, and there are typically 26 players per team. What is the expected absolute difference in inches between the combined heights of the players on a professional basketball team and the combined heights of the players on a professional baseball team? All right, so for the basketball team, we've got the total of all the players and there's 15 of them, and their average is 78. So this is for basketball. And then let's do baseball over here. For the total of the baseball players, we would divide by the number of players, 26, and that would give us an average of 74. So the total heights, if I multiply by 15 on both sides for basketball, the total for basketball is 15 times 78, which is 1,170. I did use a calculator on this one. For the baseball players, the total team height is 26 times 74. 26 times 74 is 1924. So I just want the absolute difference between these two numbers. So the difference between 1924 and 1170 is 754 inches. Probably need a calculator for that. Last two. How many positive integers are divisors of 18, but not of 63? Okay, so 18 is 2 times 3 times 3. Okay, so to find the number of divisors, this is 2 to the first. We do 1 plus 1 more, which is 2 to the 0, times 2 plus 1 more. So this is 2 times 3. There's 6 divisors in 18. So if we look at the prime factors, you look for each of your prime factors and their exponent, and then you add 1 to include the number 1, which is a divisor. And so this is a quick way to find out how many divisors. So I should get, from 18, I should get 6 different factors. 1 and 18, 2 and 9, brain's not working, 3 and 6. There's all 6 of them right there. For 63, this is 7 times 3 times 3. So again, since it's 7 to the first times 3 to the second, we should also get 6 different divisors. So we've got 1 and 63. 2 doesn't go in there, 3 does. 3 and 21. And then the next one would be 7 and 9. All right, so it says how many positive integers are divisors of 18, but not 63. All right, so we just got to take out the ones that don't work for both. So 1 works for both, so that one doesn't work. 3 works for both, so that one doesn't work. 9 works for both. So it looks like we have 1, 2, 3. 3 divisors of 18 that are not divisors of 63. And looking at this, I should have just said, oh, it's all the even divisors because 63 doesn't have any even divisors. Hindsight. All right, so anyways, it's 3. Should have thought harder. All right, so the first 3 terms of the sequence are 4, 7, and 13. Each term at the first one is 1 less than twice the previous term. What is the 6th term in the sequence? All right, so I've got 4th, 5th, 6th. All right, so 1 less than twice the previous term. Okay, so for the 4th term, I would double this, 26. And then subtract 1, that's 25. To get this one, I double this, 50, and subtract 1, that's 49. For the 6th term, I double this, that's 98, and I subtract 1, I get 97. The 6th term is 97. Oh my gosh, almost 30 minutes. I am so sorry. There goes my morning. All right, have fun, math hard. I'll see you guys later. Bye-bye.